Okay, so first question, determine whether these two given functions are inverse functions. How do you determine if two functions are inverse functions? I need to know that rule. I believe that was something you saw before. Yeah. What F and G are inverse functions. Yep. And only if that's what IFL means. Both conditions have to be true. Two conditions. Okay. F G of X is identically equal to X. That's the triple equal sign means. Identically equal to means for all values of X, F of G of X is equal to X. And similarly, G of F of X is identically equal to X as well. Well, let's test this. Okay, well, it's not written very clearly, but that is the problem you see here. Okay, so you got to do F of G of X. Equals what? You got F of X is 5X minus 2. You replace X by G of X, you get F of G of X. So replacing X throughout by G of X, we get 5 G of X minus. Of course, that's then 5 times 1 over 2X plus 5 minus 2. Good G of X, 1 over 2X plus 5. Well, that's 5 over 2X plus 5 minus 2. You could put all that over the common denominator, 2X plus 5, but it would help. You're going to have an X in the denominator no matter what you do, and there ain't no X in the denominator of just the expression X. Okay? So, this is equal to X. So these are not inverses. Now, I would go ahead and find the inverse of each function, but I've given you another problem where you're supposed to find the inverse and you're going to use the same principles. So we're not going to do that. Mind you, you saw this in your homework, okay? And if you didn't get it, I think in the class is about half and half. I do recommend that you take notes, write a summary of the things, important points. Okay, like here's how you test for inverses. Okay, you just write inverse functions, F of G of X equals X, G of F of X equals X. Okay, just have a note like that in your notebook. Okay. Okay. Then you're going to have it for reference, and you go back, and maybe you're still fuzzy because you only spent a couple of hours in the assignment, maybe on one day. You go back and look at it, remind yourself of what you did, and other things become clear when you do that. Okay, so I kind of recommend that as a strategy for learning this stuff in a way that'll get you through to the test. Okay. Okay. Now sketch the inverse function. based on a sketch. Well, to get the inverse function, you just swap x and y. Okay. So for example, you got this point here. Right, here's its x coordinate. Call this x1. Call this y1. Okay. If you plot y1, x1, this point is x1, y1. Okay. We want to plot y1, x1. Well, y1 is a positive number, it's this big. So it'll be this big over here. Okay. So this would be y1. And x1 is a negative number, about this big. So you'd have x1 down here. So you'd have y1, x1. Okay. Does that make sense? That's what happens when you swap the coordinates. You can just see what the coordinates are, assuming you have a graph where you have a good scale on both. But I put the y equals x line here. And if this is the y equals x line, then the scales on the x and the y are about equal. Okay, when they're equal scales, the y equals x line is going to make a 45-degree angle with both axes. And that's kind of what I got a little, I think maybe closer to 50 degrees there, but you get the idea. Okay. If you take another point like here, and you have maybe y2 and an x2, and this would be the point y2, x2. So you'd have, sorry, it's x2, y2. And that's going to give you the point y2, x2. Well, y2 is this big. So you're going to switch that to the x-axis. It's positive, it's over here. So here's y2. And x2 is this big. That's going to be your y-pointer. It's going to be positive. It's going to be about here. See, that up here is going to be about here. So right here is my point y2, x2. Again, take the x2, make it my y coordinate for the new point. Take the y2, make it the x coordinate of the new point. Should be able to figure it out. But you see that this point kind of connects to this one, and this point kind of connects to this one. And if you do this accurately, and I think I had my x coordinate a little too big there. Probably should be more like here. Now this point's going to be to the exact opposite side of the y equals x line to this. It's like a reflection through y equals x. And if you look, I'm sure your materials, both the math materials, showed you that, right? See that? Because that's kind of universal. Probably there in the text materials and probably there in some of the videos. Okay, well, that's a couple of points on the graph. But the point now is we can take all the rest of the points and reflect them across the y equals x line. Okay, so we have this point, and then this point on the axis would reflect out to this axis. And you connect these points, and you're going to find that they connect like this, and they'll continue to look like so. Okay. Kind of have this hourglass shape reflected through the x-axis. All right. So you want to practice until you see that. Find the function algebraically, the algebra. Well, we'll talk about the algebra as we do this, okay? So, We swap X and Y. In other words, the Y becomes X and the X becomes Y. And we leave the F out because it's a little hard to figure out where to put an F inverse in this. Okay, until you solve this for Y. Then you know what your F inverse is. Okay, so well, to solve for Y, we got a denominator here, and Y is in the denominator. We generally just want to clear out all our denominators when we solve an equation. So we multiply both sides by the 3y plus 5 by the denominator. We get 3y plus 5 times x equals 3y plus 5 times 1 over 3y plus 5. Well, this is just 1 because this 3y plus 5 is divided into this one. We get 1. And over here, we get 3y times x. We can write that as 3xy. And then plus 5x. Okay. Now we're trying to solve for y. So we want to isolate y on this side. So we're going to have to subtract that 5x from both sides. So we've got 3xy plus 5x minus 5x equals 1 minus 5x. That x is pretty good. That's why the fools sell this stuff. Put their labels on here so you can't get them off. They do. Okay, put the x there. Now we simplify. 5x minus 5x is 0. We have to add 3xy, and that just gives us 3xy. That's equals 1 minus 5x. And then we divide both sides by 3y. Get 3xy over 3y. I don't have room to write that as a fraction. Okay, and that's 3xy over 3y equals, now I will write this, equals 1 minus 5x over, and it should be divided by 3x, not 3y. We solve it y. So that's 3x, and we divide over here by 3x. And we finally get y equals 1 minus 5x over 3x. Now, if I've done this right, this is going to be our inverse function. So we can say that okay, so we can say that if f of x equals 1 over 3x plus 5, then f inverse of x is 1 minus 5x over 3. Check this. The question mark here is f of f inverse of x identically equal to x. Well, we just plug it in. f of f inverse of x. Well, we replace x here and here by f inverse of x, and we get 1 over 3 f inverse of x plus 5. Well, that equals 1 over 3 times 1 minus 5x over 3. And that doesn't look like it's going to work out. Oh, it's not 3, it's 3x. Okay, so that's going to work out. This equals 1 over this 3 divides this 3, leaving me 1 minus 5x over x plus 5. Well, it's a complex fraction, and this algebra is a little tricky here, so pay attention and review it if necessary. We're going to have to put this denominator itself over a common denominator. So that's 1 over 1 minus 5x over x plus 5x over x. Because now the 5 is expressed as 5x over x. It's still equal to 5, but it's expressed this way, so we can add these two fractions. That equals 1 over well, the numerator is just going to be 1 minus 5x plus 5x. And the denominator is still going to be x. And of course, all that is the denominator of this complex fraction. Well, 1 minus 5x plus 5x is just 1. So this is 1 divided by 1 over x. Which is 1 times x over 1, which is just equal to x. So sometimes you got to do a little bit of algebra to verify that you really have an inverse function. Now this is only f of f inverse of x equal to x. That's a pretty good check. Then we should also check that f inverse of f of x is identically equal to x. I'm not going to work through all the algebra there. It's very similar type of steps you use. The algebra we have here. But the algebra gets a little bit involved. Okay. A lot of functions, it's easy. And good thing algebra doing this, be a little bit involved. And they're much worse examples. Okay. If I had like f of x equals 4x minus 3 over 3x plus 5, the algebra get even a little bit trickier. Nothing that you shouldn't know, but people tend to be rusty on their algebra when they come in. So, we might ask you to do another example just to see how your algebra looks, because we could take a little time to talk about the algebra, okay? Although, for a pre-calculus course, we really need to assume that you can do this much algebra. The fact is, most people can. And this is a support course, if that's the support you need, and that's what I'm going to. The next assignment you have is on linear functions. Things get a lot easier. Okay. It's kind of a peak of difficulty right here at the end of chapter 1. Then in chapter 2, it gets easier. Then in chapter 3, it's not too bad, but it's a little harder in chapter 2. Then there's a second half of chapter 2, where the last topic is the hardest thing in the course. Then get into exponential functions, things get a little easier. There's just one thing you got to know, which is the inverse function of the exponential function and how to use it. And that's a pretty simple function, okay? So your difficulty level kind of goes here, we're at kind of a peak, then it comes down a little bit, then it comes up, then it goes a big peak, and then it comes down. And assuming that you have half decent arithmetic skills, and if you don't have them, you're going to have to develop them. The last thing on matrices shouldn't be difficult at all, but many people find that it is. Not as difficult as the rational functions. So that's kind of where we are. This is this may be the second hardest thing. Getting inverse functions and stuff. Now, knowing the rule, which is just swap x and y, which is what we did here. That's what we do here, and that's what an inverse function is. That should be straightforward. You should know to write this down and try to solve it for y. If you know that much, I'd probably give you half credit. Okay, but for full credit, you have to do the algebra. And you do most of the algebra, and you might get 7 out of 10. Okay, but if you screw it up, and then do a good attempt to check it and find out that you screwed up, I'll give you 8 points out of 10. Okay, that makes sense. I don't know. Some of you are in my class and some are in another class. So I don't know how other instructors would grade that, but that's how I personally grade it. Okay. Here's partial credit. And some instructors want everything right, 0 or 1. Okay. 0 or 10 points. Don't think anybody really does that. But if you got an online test, it's hard to get partial credit. Something to get wrong. I saw in the homework, I forget who did it. Somebody's giving the domain of a function, and there were 3 intervals in that domain. And they knew what the 3 intervals were, but they put the U inside the parentheses, the union sign inside the parentheses. So open math said, no, that's terrible, no points. Well, I haven't gone back to regrade it, but I will give probably at least half credit on that with a note to say, hey, careful where you put that union sign. That didn't make any sense. And open math isn't smart enough to see that. Okay. Having open math isn't very smart. It's well set up on the whole. Different people write these problems and write the grading algorithm. Okay. And I wish I had time to go through and write a complete set of problems for this course. And it's something that's kind of here on my priority list. I've got all these things ahead of it, so it's not getting done. Also, I mean, I selected the problems, and I think it's a good set of problems. Okay. But sometimes the grading is a little minus. And hopefully, try to get credit what you do. Okay, well, enough of the digression on that. Let me ask you to do this one, because the algebra is quite a bit easier. Find out inverse of x for that, and then check it. Because checking it is always part of doing the problem. Okay, so starting solution here, f of x equals 3x plus 7. We're going to find f inverse of x and check. Most of you either have the inverse function or we're moving in the right direction. So we swap x and y, and we get upward y equals. We got y equals 3x plus 7. Make this an x, make this a y. And then we solve for y. Then we're going to get x minus 7 equals 3y plus 7 minus 7. Be sure you're writing out these steps coherently, because if you don't, you tend to get lost. Okay. So we get x minus 7 equals 3y. Then we're going to divide both sides by 3 because we want to solve for y. Actually, first, we're going to go ahead and put the y on the left, the x on the right. Okay. Then we divide 3y by 3, give us just y. Of course, we have to divide the other side of the equation by 3. So we get x minus 7 over 3, and 3y over 3 is just y. That's x minus 7 over 3. The inverse of x equals x minus 7 over 3. Check this. F inverse of x, we look back at the definition of f of x and see that we're replacing x by f inverse of x. That's going to give us 3 f inverse of x plus 7, which is going to be 3 times x minus 7 over 3 plus 7. 3 times x minus 7 over 3, this 3 divides this 3, we end up with x minus 7. And then there's a plus 7, and that's obviously equal to x. So this is okay. Now we want to check f inverse of f from x. Well, and we look at the definition of f inverse of x, replacing x by f of x, we get f of x minus 7 over 3. Of course, f of x is 3x plus 3. Yeah, plus 7, I don't know what got 3, that doesn't work. Obviously, it's 3x plus 7. I don't know what I was thinking to look at that. Anyhow, we replace f of x by this, and we get this. It's divided by 3. Of course, that's just 3x over 3 because 7 minus 7 is 0, and 0 plus 3x is 3x. And dividing 3x by 3, we get x. That's okay. So we check it. All right. Now, it's a real straightforward process if you have a linear function. If you've got a linear function, the denominator gets a lot harder. Okay. Okay, we're gonna switch gears a little bit. Okay, I just wanted to check, make sure I remember, and I kind of remember, not as specifically, like how the text and the open math assignment approach this. So I'm going to approach it just a little bit different. I'm going to start with a picture. We started with these 2 points. That's all we have. Then I drew a straight line. And now I've drawn a path from this point to this point, consisting of only horizontal and vertical line segments. So I chose to go horizontal first and then vertical. Okay, I could have drawn one up here. I go vertical, then horizontal. This is good. Makes no difference wherever it's easiest to label or wherever you want to see it. That's fine. This is, I call this a fundamental triangle. Okay. Now, if you haven't copied that, I'll go ahead and tell me what's the displacement from here to here? In other words, how far is it from here to here? And is it positive or negative, right? And how far is it from here to here? Think about that for a minute. See if you can write down how far it is, so you can just kind of label that on the graph. Okay, well, from -5 to 7, well, -5 to the y-axis is 5 units, right? And from the y-axis to this point is 7 units. Moving horizontally, so that's going to be 5 and 7, which is 12, right? And you might well see it that way. Okay, so there's no doubt that that's 12. Again, from here to here is 5, from here to here is 7. This is -5 and 7. Okay, and then what do we have? From here to here is 5, right? But from here to here is 1, right? So 1 and whatever this is has to add up to 5, so this has to be 4. Now, there are many ways to see it. Now, there are easy ways to calculate it. I'm not in favor of using a formula to calculate it until you see it, which is why we start with seeing it. Okay, open math just might give you a formula without requiring you to see anything. All right. And you're going to understand the formula a lot better if you see it. And most people tend to remember this formula, which means the formula's been drilled into them, but the idea hasn't necessarily. Sometimes it has, sometimes it hasn't. Okay, so this 12, we can reason it out because we know it's 5 from here to here and 7 from here to here, and that adds up to 12. There's an easy way to calculate it, which is this x coordinate minus this one. 7 minus -5, right? And we're going to call that the run. This point to this one, we run this way and then we rise this way. Okay, so we've got a rise and a run. Okay. Now, get this, we do the same thing, but it's the y coordinates to determine how far this is because x isn't changing on this line. Okay. Y goes from 1 to 5. So we could calculate that as 5 minus 1 equals 4. We call that the rise. Make sense? Pretty straightforward. Okay. So we always subtract where we end up from where we start. I'm sorry, where we start from where we end up. We do where we end up minus where we start. Okay, it makes sense. From here to here, it moved in the positive direction. So we do 7 minus -5, we get 12. And of course, there are details of calculation. You do minus -5, same as +5, just to remind you in case of confusion on that. Okay. Then, what's the definition of slope? Okay, now I'm making a statement here, and mathematical formalists will disagree with me, but mathematical intuitionists will be happy. Okay, and most people in pre-calculus need intuition more than formality, but we have to develop both. Now that probably doesn't make any sense to you at all, but my point is that when we find the slope, most people want to quote a formula, y2 minus y1 divided by x2 minus x1. And as I said, a majority of pre-calculus students don't seem to know what that means. Okay, so the definition of slope is rise divided by run. As you can see that easily on this picture. Okay. Now the rise is y2 minus y1. Here's y2, here's y1. We did 5 minus 1, that's y2 minus y1. Okay. But we start with the idea of rise divided by run. And then we say, well, the rise, you have to subtract the y coordinates, the later one, the earlier ones. So that's like y2 minus y1. And the run is very similar, x2 minus x1. You remember rise over run because it gives you a picture, whereas the formula doesn't. Now, maybe the formula does. If you connect the formula immediately brings to mind a picture. And the picture would be like this. Okay. And if you know that's the rise and that's the run, and you might very well, okay, but we want to have an intuition about it. Okay. Well, in this case, it's rise over run, which is 4 over 12. And of course, that's 1/3. I'll put a little box around that because usually I tell people label the run here, label the rise here, and label the slope here. But the number you put down for the run is a distance or displacement. Okay. The number you put down for rise is a distance or displacement. And the number you put down for the slope is not this distance, right? Get this distance, you use the Pythagorean theorem. But we're not going to talk about that right now because we're going to talk about straight lines. We've only got 4 minutes left. Okay, so the slope is 1/3. I put a box around that to remind myself that that's not the distance from here to here, that's the slope. Okay. All right. Well, now, equation of the line. Y equals mx plus b, where m is the slope. Okay. So the equation is y equals 1/3 x plus b for some number b. Now, since y equals 5 when x equals 7, y equals 5 and x equals 7, we can plug in 5 for y and 7 for x. If we do, we get this equation that we can solve for b. How do we solve this equation for b? I'm going to multiply the numerator and denominator both by 3, which is the common denominator of the whole equation. Okay? We get 3 times 7 equals 3 times 1/3 of 5 plus, oops, my parentheses, plus b, not 5. Okay. And then we distribute, we get 21 equals 5 plus 3b, which is really easy to solve now. That's why we multiply by the common denominator, so we don't have to work with fractions. We'll get a fraction at the end, but we don't have to work with them to get there. And I realize that some of this is not quite on the board for everybody. Okay, so, well, we're going to subtract 5 from both sides, get 16 over here, divide by 3. We're out of time, so I'm just going to write the solution. B equals 16 over 3. Oh, that's 3 is and 16 over 3 thus y equals 1/3 x plus 16 thirds. And we can check it. We're out of time. We check it by plugging in the coordinates of this point and the coordinates of this point. Make sure it works for both points. So if x equals 7, we get 7/3 plus 16 thirds. Which is 5, so I must have done something wrong in the calculation. Okay, if I put in -5, I get -5 thirds, get 11 thirds, something's wrong with my solution. Oh yeah. That'd be right. Okay, anyhow. I don't see anything wrong with the calculations, there might be something. But if I plug in 7 here, I should get 5. I don't, but I should get 5. Okay, if I plug in -5 here, I should get 1, but again, I don't know why not. So some really ignorant things. So if you just take this for practice and take this equation, okay, I mixed up my 7 and my 5. Wrote it down wrong. This should have been 5. This should have been 7. If you solve this and use the number you have for b, you're going to get the right equation. Then if you plug in the x coordinate of one of these points, you're going to get the right y coordinate. plug in the x coordinate of number one, you're gonna get the right one. Okay, so
They will.